All right, so quadratic functions, there's actually 3 forms of them, and today we are just going to look at standard form, which is y equals ax squared plus bx plus c. So the first two, it kind of looks like the same thing, but standard form is the actual, just the equation, and then a quadratic function can be written as, technically anything with an x squared is a quadratic function. Even if it doesn't look like ax squared plus bx plus c. It could just be x squared. It might look differently. We'll look at some more of those next week. But if it's got an x squared in it, it's a quadratic. So you can go ahead and finish copying the vocabulary, and we'll pick up after that. Okay, so the name of a quadratic graph is a parabola. It is the U-shaped graph. If you wanted to, you could draw the U shape if you want to. Remember, they can face upward and look like a U shape, or they can face downward and look like lowercase n, a hill, however you want to remember that. Okay? The vertex is probably one of the most important things that we're going to be working with quadratic functions. It lets you know where you're putting the graph on the coordinate plane. And it's usually, when you have a quadratic function, you're either finding the vertex or the x-intercepts. Almost always. And then extrema are minimums and maximums. A quadratic function will only have one. It will either have a minimum, which is a lowest point, or a maximum, which is a highest point. And then the axis of symmetry goes down through the middle of the U. And because it does that and slices directly through the middle, it's also going to pass through the vertex. Okay? Excuse me. So the axis of symmetry is important because if you look at that formula right there, okay, this is how you find the vertex when it's in standard form. So in ax squared plus bx plus c, that's what the standard means. Okay, so this is the formula we're going to use. Negative b over 2a is how you find the axis of symmetry, which from here on out we'll refer to as the AOS. So you don't have to write out those big long words. So the axis of symmetry, or the AOS, is found by negative b over 2a. All right, and then what we mean in the y value of f of negative b over 2a, remember that's what that notation means when you have an f in parentheses. It means you're plugging in whatever value you got for your axis of symmetry. You're going to plug it back into your equation wherever you see an x. If it's in standard form, you're probably going to have 2 places to plug it in. When you simplify that and you get your answer, that's the y value. Okay, so if you wanted to write like plug in AOS or something over here. So you find the axis of symmetry, that's the x value of your vertex, plug it back in, and it gives you the y value of the vertex. So we'll try that with a few examples here. And you'll notice on these examples, there's a little table, an XY chart to the left. That's the best way to make an accurate graph with these, okay? So we'll make the table shortly once we find the vertex. Okay, so if we look at the first example, y equals negative 2x squared plus 2. Is this technically standard form, ax squared plus bx plus c? It is, okay. There's no parentheses or anything, but what's missing? The bx is what's missing, right? We have just a number, so 2 is our c, negative 2 is our a, so if the bx is missing, then what is the value of b? It'd be 0. Yeah, if it's not there, then b equals 0. So a is negative 2, b is 0, c is 2. So remember, the way we find the axis of symmetry, and that's always where you want to start, is with the axis of symmetry first. Negative b over 2a. So we'll do negative 0, right? We said b was 0, over 2 times, what's our a value? Negative 2. All right, so that would be negative 0 over negative 4. Okay, first of all, is there such a thing as negative 0? It's the same as regular 0, right? And then what's 0 divided by anything? 0. Okay, so this is just 0. And actually, once you got to the step of realizing that b was 0, you could have just automatically known your axis of symmetry is going to be 0. Because if you make 0 negative, it's not going to matter. If you divide 0 by something, it's not going to matter. It's just 0. So if b is 0, you can write that down if you want. If b is 0, then the axis of symmetry is automatically 0 as well. Okay, saves you some time if you remember that. All right, so the axis of symmetry is 0. The axis of symmetry is an x value, so you could either write 0 or x equals 0. So how do we then find the other part of the vertex? Sorry. Yeah, we're going to plug in the axis of symmetry value, which is 0, back where we see an x. And there's only one x in this function, right? If there were 2, you'd plug it in both places. All right, so negative 2 times 0 squared plus 2. How's that going to simplify? Negative 2 times 0 squared. What's that entire first term going to equal? Just 0, right? Because 0 squared is 0. Negative 2 times 0, still 0. All right, so we just have 2. So, and they didn't really give you a place to write it. Your vertex is 0, 2. Because remember, the first coordinate is the axis of symmetry value. Second coordinate is what we get when we plug it in, which was 2. So we're going to plot our vertex at 0, 2, which is right there on the y-axis. All right. Now, does anybody remember the front number of the function is negative 2? Does anybody remember what the fact that it's negative is going to do for us? It's going to make it flip upside down. Yes. Instead of being an upward facing U shape, it will be upside down. Does anyone remember what the 2 does? No. We'll get to moving it left or right when we do vertex form. Nope, not up and down. The plus 2 at the end is what did that. Yeah, this 2 is going to affect how wide or how narrow it is. And since it is greater than 1, it's going to make the graph narrower, all right? But just to make sure exactly how narrow, the best way to do that and get an accurate graph is to make a table. So what values should we plug in for x? What do you usually use when you're making a table? Yep. Yeah, negative 2, negative 1, 0, 1, and 2. We choose those because they are symmetrical around the origin, right? Okay, so you're going to plug them in. If you want to use a calculator to help you plug numbers in, it works just a little faster. I'm okay with that, but I still need to see a table, okay? With something like this, it shouldn't be too difficult to plug in. No, there's not a lot of room for you to write if you need to use the back or something, that's okay. So if we did negative 2 times negative 2 squared and then plus 2, what do you do first in all of that? Remember your order of operations. What's going to go first? Right, the parentheses, which is just a number, so we don't need to do anything with that. So what's next? The exponent, right? You always do the exponent first. So what's negative 2 squared? Positive 4, all right? So negative 2 times positive 4 would be negative 8. And then negative 8 plus 2 would be negative 6. So our first coordinate would be negative 2, negative 6. And then you would just proceed with filling in the table. Now, does anybody remember these graphs are symmetrical, right? The axis of symmetry cuts it into 2 mirror images. So what do you think if we have a point over here at negative 2, negative 6? Can we use that to get another point without having to plug it in? Could we do that? We can, right? If the graph is symmetrical over the axis of symmetry, which is right here, it means any point on the left side will have a companion point on the right side in the exact same place. So if this point is at negative 2, negative 6, reflected across that line, it would be at positive 2, negative 6. Right? It's like folding the graph across that line. Everywhere there's a point, you should have another point that shows up on the other side. So positive 2, negative 6 would be another point. And we don't even have to plug it in. So you can use that as well with your table. If you can just plug in one side, you're going to get the other side for free. All right, let's plug in negative 1. And again, you can use a calculator to help you do these as we move forward. It just makes it a little bit faster. So square the negative 1, that'd be 1. Negative 2 times 1 is negative 2. And negative 2 plus 2 is 0. So our point at negative 1 would be 0. So what companion point will you get on the right side of the graph? What do you think? 0. But where will it be? At what x value will the 0 be? At 1, yeah. From negative 1, 0, it'll reflect over to 1, 0. Oop. Okay, do we need to plug in 0 for our table? We already did that, didn't we? Okay, down here. We were finding the axis of symmetry. We already know what that is. So we actually only had to plug in 2 numbers to make our table work. That's the nice thing about quadratic functions. As we go through the semester, we will graph other types of functions where it's not the same and they aren't mirror images. But for these, if you just plug in the points on one side, you'll get the points on the other side for free. And if you've already found the vertex, you get that one. Okay, so then you just draw your graph. And remember, it does keep going even though our coordinate graph ends, so we put arrows on it. Okay, do any of you remember how to do domain and range? One of the most hated things in all of mathematics. The domain represents the what? The x values, and so the range is the y values. All right, so for domain, it's actually relatively easy if you can remember 1 or 2 things, okay? There are only 2 types of functions up to this point that we know that don't have a domain of all real numbers, okay? So remember, this is our symbol for all real numbers, or you're welcome to write out all real numbers. That's fine too. So the domain is going to be all real numbers for every type of function except if x ends up in the denominator. Okay, so that one wouldn't be all real numbers. And except if x ends up under a radical. Because we can only take the square root of positive numbers. Well, now we can take the square root of negative numbers because we learned complex numbers. But when we graph them on a real x and y axis, we can only use positive numbers. So if you don't see one of those 2, the domain is all real numbers, unless it's a word problem. Word problems are awesome, right? You got to think about those in every situation. So is this a quadratic function? One of those 2 exceptions. It's not, right? The x is squared. So what's our domain? All real numbers. You can go ahead and fill in the rest of the page. They're all going to be all real numbers because it's not one of our 2 exceptions. Okay, so domain taken care of for virtually every other function we're going to do. What about the range? What y values are we using? Are we also using all real numbers for the y's? Or is there a limit on the y's we can use? The way you answer that question is you need to see, well, first of all, the y-axis goes what direction? Up and down. So if you look at the graph, looking up and down, is there any stopping or starting place? It has a starting place, right? Right here at 2 is where the graph begins, and then from there it goes down, right? If you go up and down along the y-axis, there is no graph up at the top, right? Up here, nothing's there. So we're not using those y values. Our y values begin at 2 and go down from there. Is everybody okay with that? So how would we write that? That our y values begin at 2 and go down from there. Okay, we can either write it in interval notation, which we would say it goes from negative infinity to 2. Or the other way we could write that is y is less than or equal to 2. Either one of those, for me, on a test or a quiz, is perfectly acceptable to write. Anytime we're taking notes or practicing, I'm going to write both because we never know how it's going to show up on an EOCT or a county exam. Okay. Sometimes they use the interval notation with the parentheses. Sometimes they use the inequality. So we'll practice both. You can pick the one that makes more sense. And actually, technically, because I would put equal to on my inequality because the point of 2 is included, this bracket will need to be closed for interval notation, a square bracket. I don't know if you remember that about interval notation, but if you're including the point, you make a square bracket. If not, then it's just rounded. And infinity is always rounded because technically infinity is not an actual number, right? It's an idea. That's a mind blower for an early Friday morning. All right, what do we think? The most important thing that you can take from today's lesson, because I know we've done a lot of things here, is this negative b over 2a and plugging that in. That's the most important thing that you need to remember about standard form. Because once we learn the other two forms, each form has a different way to find the vertex. So if you can remember this thing that we did right here, the negative b over 2a, and then plugging it back in, you're good to go. So let's go ahead and look at the next one. All right? Need to do our negative b over 2a. What is the b value here? B is 4. We actually have one. What is a? Yeah, it's negative 1, right? There's not a number there, so it's technically a 1. You can write one in if you want. And c would be negative 3. So negative b over 2a would be negative 4 over 2 times negative 1. So that's negative 4 over negative 2, which would simplify to just 2. So that's our axis of symmetry. How do you find your vertex? We're going to plug that number back in. Okay, so we know it's 2 something. We'll plug that back in. So negative 2 squared plus 4 times 2 minus 3. Okay, remember your order of operations again. We have negative 2 squared. You have to do the exponent first. So you're going to do 2 squared, which is positive 4, then make it negative. Okay. If you are using your calculator to type these in, which again, I've encouraged, that's fine. Do use parentheses around the number every time you substitute it. So the way I've written it here, if you will type it into your calculator just like that, then you'll get the right answer. If you start dropping the parentheses, there is no guarantee that it's going to be correct. But if you put the parentheses around your number, you'll be fine. So negative 4, 4 times 2 would be 8, and then minus 3. We add all those together. We get 4 minus 3, which is 1. So the y value of our vertex is 1. So we put our graph at 2, 1. There's our vertex. Okay, does this graph open up or down? Remember, how do we tell? You look at the front. If it's negative, it opens down. The last one was y equals negative 2x squared, so it went down. This one is negative x squared, so it's also going to go down. And that comes in handy when you're taking a multiple choice test and you're not actually drawing the graph, because you'd most likely be just choosing from 4 graphs. So you make sure you pick one that's opening down. Any that don't open down would automatically be eliminated. Okay? Yes. Sorry. There's like nowhere to go. Is that better? All right. What numbers would we plug into our table? We still want to use negative 2, negative 1, 0, 1, 2? Okay. We can use those. Here's the thing. In the last function, 0 was the middle number and 0 was our axis of symmetry, correct? What is our axis of symmetry here? Not 1. Axis of symmetry is 2, right? The x value. Shouldn't the axis of symmetry technically be the middle number in our chart? That would be helpful, right? Because then we're actually going to get the U shape. So what if we put, instead of 0 in the middle, what if we put 2 in the middle? Because that's our axis of symmetry. That's where the middle of the graph is. What do you think? It would be more helpful if we did it that way. Now, what does that mean the 2 points to the left of that are going to be? What 2 numbers are to the left of 2? 0 and 1. What 2 numbers are to the right of 2? 3 and 4. Okay? You do not have to do that. You could plug in -2, -1, 0, 1, 2. Here's the thing. Since 2 is the middle, if you plug in -2, all your points are going to be over here. So you're just going to get that side of the graph. You're not going to get anything on the right side. Now, we can reflect them over, right? So that would work. But you would end up with 5 points that are only on one side of the graph. It works a lot better if we get 2 on one side and 2 on the other side. So let's plug in 0. Again, you can use your calculator if you want to. So -0 squared plus 4 times 0 minus 3. Okay, what are we going to do with 0 squared? What is 0 squared? 0. So that's gone. 4 times 0, 0. So it's just -3. So we'd use 0, -3. What other value then is going to give us -3? Remember, we can reflect them. If you've got your chart lined up with the middle number being your axis of symmetry like we do, then 2 to the left will be that. 2 to the right would also be -3. So we'd have 0, -3, and 4, -3. All right, plug in 1. -1 squared plus 4 times 1 minus 3. -1 plus 4 minus 3. What would that be? That'd be 0. All right, so we have 1, 0 reflected across the axis of symmetry, so you'll get 3, 0. And then we already plugged in 2, right? That's our vertex. 2, 1. So there we go. There's our graph. Okay. What would the domain and range be? Which one is all real numbers? The domain is all real numbers. What's the range for this one? 2. Is it 2? 2 was our y value last time, right? Remember, range is y values. So what is our starting y value here? 1 is the y value, right? So we're going from 1. Are we going down or up? Down, right? So that would be from -infinity to 1, or you could say y is less than or equal to 1. And I forgot, square bracket again. Okay. All right. So if you feel sort of comfortable with it, want to try the last 2 on your own, go for it. Also go over them if needed, but if you want to try them and then just see if you get them right. Remember, you always start with -b over 2a. When you're in standard form, that's the first place you go. Find your axis of symmetry, then plug it in. Now remember, if you have a graphing calculator, how many of you have one? I know just about everybody. If you don't, it's okay. You could still use your calculator, plug the numbers in, and make it go faster. Graphing calculator, if you don't already know how, you can look at the graph, obviously, and you can use the table. Do any of you know how to use the table on your graphing calculator? Okay. You would still type your function into the y equals, put it in y1 equals whatever. Type in your function, and then instead of hitting the graph button on the right side, you would press second graph where it says table, and it's going to bring up a table. Now, depending on how your calculator is set, it might already have numbers in it, or it might be blank. If you want to change that, I can help you with that. You can you can program it to ask you what numbers to type in, and you type in which numbers you want, or you can just have it already listing and you just scroll through the numbers. Either one works. So that helps as well. Just a reminder, on the EOCT, which we take in May, we can't use the graphing calculator. So don't get to where you can only do this on a graphing calculator. You'll be in trouble later. Okay, whoop. Okay, last one. B is -4, A is 1, C is 2. So that'd be +4 because you do -4. 2 times 1, 4 over 2 is 2. Okay, plug that back in. 2 squared minus 4 times 2. So 4 minus 8 plus 2, that's 6 minus 8, -2. So our vertex is 2, -2. Right there, okay? It's positive, so we know the graph is going to open up. What number, remember, here's our axis of symmetry at 2. So it'll be helpful if we put 2 in the middle of the chart. If you don't do that, it's okay. But you'll get a better picture of your graph if you do that. So then we'd have 3 and 4 to the right, 1 and 0 to the left. We already know that 2 is -2. If we plug in 0, 0 squared minus 4 times 0 plus 2, those cancel. So it's just 2. So if 0 is 2, remember when your chart is symmetrical around the middle, then the pairs of numbers work out. So that'd be 4 and 2 down here. So 0, 2, 4, 2. Plug in 1. 1 squared minus 4 times 1 plus 2. 1 minus 4 plus 2 would be -1. And remember, it's partner point would be on the other side. There you go. And if the whole thing about reflecting the points over isn't making sense, then you can just go ahead and plug the other numbers in, and you'll get the same values. And once you practice it enough, you might start to catch the pattern. Oh, they are just pairs of points, and then you can reflect them. But if you need to just plug them all in or use your calculator to give you all the table, that's fine. Okay, so no homework with these. We just got these 4. We'll finish up with it. Remember, we're not here Monday, so finish up Tuesday.